Hey guys, welcome back to my channel, Civil Tactics. Today we're going to talk about engineering shop drawing review. I am Deepika, a structural engineer who works in New Jersey, USA. So let's get going to the next slide. What is shop drawing? It is a detailed fabrication and installation drawing prepared by contractors, fabricators, or suppliers showing how contract requirements will be implemented. So they depict how specific component of a project will be fabricated, installed, or assembled. These drawings include critical information such as dimensions, materials, finishes, and other details not found in the main construction document, which is the contract drawing. Shop drawing plays a critical role in ensuring that final construction matches the original design intent and adheres to all specified requirements. Shop drawings are subjected to a review and approval process by architects, engineers, and other relevant professionals involved in the project. This review process is done to confirm that the proposed drawing details comply with the overall project specifications. There are various important factors while checking shop drawing. The universal checks that you need to do for a shop drawing would be checking the cover sheet first. Check if the specification section is mentioned several times. The file name also has specification number along with the submittal number in it. You will also see the revision number in the shop drawing cover page, and you will see the material designation, you will see the location and description. There are other things that you will see in the cover page as well, such as date that was created. You will see the due date of this shop drawing. You will also see whom you received it from, and you will also see what is the status of this submittal. And according to the priority, you have to do your shop drawing. Second important thing you see in the shop drawing is what category is it, which discipline you need to review it. Reinforcing steel, structural steel, casing, CIP concrete, or precast concrete. Or there are many other discipline review as well, which we will talk at the end of the video or in the middle. We'll see. And then after that, we check the interface review, which says fit up between concrete, steel, embeds, joints, rebar cases, and erection or placement constraints. The number 4 factor is approval comments, prioritize issues that affect safety, geometry, constructability, durability, and field execution. Let's go to another slide. EOR review objective. The objective of the EOR review is to verify the compliance with contract drawings, specifications, design intent, constructability, coordination, certifications, and safety. Approval of shop drawing is needed before any fabrication or installation work can begin on the construction site. This drawing helps in identifying any potential issues or discrepancies between the design and the practical aspects of construction, allowing for adjustment before actual construction starts. Shop drawing acts as a bridge between design phase and the construction phase. Universal EOR review checklist. Submittal control. Package or package reference. Latest revision, complete sheet set, and contract drawing citations. So in any shop drawing, you will see which package it came from, and you will see which revision they used. You will see the complete sheet set, and you will see the contract drawing citations, such as which sheet they use, the which sheet number they use the from the contract drawing to make the shop drawing, and most of these would be just below the shop drawing. Material control. You will see on the right hand side mostly you will see the material control, which is ASTM or ASTER grades, coatings, weldability certifications, and specification consistency. So whenever you receive any shop drawing, you will expect these things, otherwise you need to mark it up. Usually the certification will be included in a separate submittal. Technical control. Dimensions, geometry, interfaces, constructability, and comment closure from prior review cycles. Let's go to another slide. Major shop drawing categories. reinforcing steel, structural steel, casing, cast-in-place concrete, precast concrete, temporary works, bearings, expansion joints, foam work. Rebar drawing focus points. For bar data, you need to check the size, grade, coating, bar marks, schedules, cut lengths, and bend shapes. Usually, you see a table on the top right-hand side of a shop drawing where you see the size, bar marks, schedules of a shop drawing. You need to make sure these match the contract drawings. Placement and cover. Spacing, orientation, layer order, clear cover, and section consistency. You need to make sure the spacing and the clear cover is matching. If not, check with the designers. Splice requirements, lap length, development lengths, hooks, couplers, and welded splice conditions. Constructability, congestion, concrete placement access, case lifting, chairs, and strandies. Make sure these are all included in the shop drawing. Documentation, mill test reports, coating certification, coupler certification. There will be WPS, PQR reports. Make sure these are also submitted separately. Mostly whenever shop drawing is submitted, whenever you review it, you might not see a mill test report in the same file. Make sure you check the mill test report and other certificates are there for this shop drawing. Typical comment, missing cover dimensions or unresolved congestion around blockouts, joints, or embeds. So we will see what's next. Before that, the universal checklist that you need to do for any shop drawing would be checking the specification section, project and package reference, contract drawing reference, submittal number, and revision. You need to check the material requirement for every shop drawing that you receive. Make sure that is matching the contract drawing. And you need to check the bar mark schedule, bar placement, concrete cover, bar spacing, lap splice length, construction joint, curve reinforcement, section details, connection details, notes and references, revisions. So I will give you a simple memory trick by the end of the video so that you would understand every shop drawing. Also, I will tell you a golden rule to remember the difference between structural steel shop drawing and reinforcing steel shop drawing. Also, the major differences between cast-in-place concrete versus precast concrete by the end of this video. Let's start with structural steel drawing focus point. Before that, let's know what is structural steel shop drawing. Structural members you can physically see after construction unless enclosed, such as beams, columns, and connection plate. The skeleton or frame of the structure is the structural steel shop drawing. It is used for canopy framing, pile foundation steel, girders, frames, sign structures. The typical components are wide flange beams and columns, plates, angles, channels, HSS member, gusset plates, stiffeners, base plates, anchor rods, bolt and wheels. Example includes canopy framing, girder diaphragm, sign structures, steel frames, pile foundation structures, steel details. Drawing focus points. The things that you need to check is the member verification, WHSS, plate angle, and channel sizes, material grades such as ASTM, A709, or can be some other ASTM, camber where required, connection verification, bolt sizes, grades, spacing, wheel sizes, wheel types, plates, stiffeners, and splice details. Also, you need to verify the fabrication, check the hole location, fit up tolerances, coatings, metallizing or galvanizing, plus MTR and welding records. The certifications might include MTRs, board certifications, WPS or PQR, and welder qualifications and coating certifications. You need to check the spec. What are the certifications that are required for this structural steel shop drawing? Let's talk about casing stop drawing. Casing stop drawings are used for temporary or permanent steel casings installed in drill shafts to stabilize excavations, control groundwater, and maintain shaft geometry. Unlike reinforcing steel drawing, casing drawings focus on the steel itself, its fabrication, handling, and installation. It is used for drill shaft temporary or permanent casing. The unique items to check for casing stop drawing is outside diameter, inside diameter, wall thickness, embedment, segment lengths, annular space, and clearances for the rebar case and trimmy. Types and durability. Temporary versus permanent casing determines corrosion requirement, removal needs, and long-term detailings. Splices, seams, handling. Seam weld details, splice continuity, stiffener rings, lifting locks, segment weights, and handling geometry. Installation tolerances. Roundness, straightness, cutting through details, and extraction procedure if the casing is temporary. So the main item to check is for category geometry, you need to check diameter, thickness, and length. For category fabrication, you need to check segment lengths, seams, splices. For welding, you need to check WPS, weld sizes, and qualifications. For handlings, you need to check logs, weights, and stiffeners. For installation, you need to check the cutting screws and extraction procedure. For coordination, you need to check rebar case and trimmy fit. For certification, you need to check if MTR, welding, and coatings are provided or not. So let's conclude that the type determines corrosion requirements, splice details, and whether removal procedures are required. Now let's talk about CIP drawing review priorities. Before that, what is CIP concrete? Concrete is poured directly at the project site into formwork and cures in its final location. It is used for piers, footings, pile caps, deck slabs, moment slabs, barriers, and walls. Main purpose of CIP drawings that it shows the exact geometry and details needed to build the forms, place reinforcement, install embedded items, and sequence the concrete pour. The unique items to check. Detailed items to check in CIP concrete drawing is the geometry, formwork details, embeds and sequencing, construction joints, pour sequence, concrete cover, coordination, and finish requirement. For geometry, we need to check overall dimensions, slopes, chambers, recess, blockouts, opening, penetrations. For formwork, we need to check formwork dimensions, keyways, construction joints, and bulkheads. You also need to check the embedded items such as anchor bolts, bearing plates, conduits, inserts, and water stops. The other things you need to check is the construction joints, locations, reinforcement continuity, joint preparation requirement. You need to check the concrete cover. You need to check the finishing requirements such as surface finish class, architectural treatments, foam, liner locations. Let's move on to the precast concrete shop drawing. Concrete elements are fabricated in a control plant, cured, transported to the site, and erected into the place. Typical application is precast deck panels, retaining wall panels, pre-stressed girders, precast pile gaps, sound walls. The main purpose of precast shop drawing is to show fabrication, reinforcement or pre-stressing, lifting, storage, shipping, and erection detail. The major items that we need to check in precast concrete drawing is the fabrication geometry, which is the exact dimension, thickness, age treatments, match cast features, reinforcement or pre-stressing layouts, release strength, and mix requirements. Also, we need to check the handling such as lifting inserts, pick point location, support points, shipping orientation, and temporary bracing. Also, we need to check the erection such as bearing pads, field connection, grouting, sealants, tolerances, camber, sweep, water pace, and fit up. Next, let's move on to the another slide. Key review differences is structural steel is a connection and fabrication, rebar placement and splices, CIP geometry and pour sequence, precast fabrication, lifting and erection. Let's see the key differences between structural steel versus reinforcing steel. Structural steel review is the connection and fabrication heavy. Reinforcing steel is placement, spacing, cover, and development heavy. So the main material that we use in structural steel shop drawing is beam, column, plates, etc. Whereas for reinforcing steel shop drawing, we use rebar embedded in concrete. For item main focus, we use connection and fabrication for structural steel shop drawing, whereas for reinforcing steel shop drawing, we use placement and splices. For key stakes that we do on structural steel shop drawing is bolts, welds, holes, coatings, whereas for reinforcing steel shop drawing, we check cover, spacing, and development length. Typical codes for structural steel include AISC, AWS, RSSC, whereas for reinforcing steel, we use ASTO, LRFD, CRSI, depending upon where you live, which state, which country you live in. And the visible after construction is usually yes for structural steel shop drawing, whereas for reinforcing steel shop drawing, it's embedded in concrete, so you can't see it. So while reviewing any shop drawing, you need to keep in mind that your shop drawing is matching with the contract geometry. You need to check if there is any missing or incorrect material and certification differences. You need to check constructability conflict as interference, congestion, or field access. You need to see if there is incomplete lifting, shipping, splice, or fit out detail. Common reasons for rejections are if there are missing certifications, specification, non-compliance, incomplete connection details, incorrect material grades, missing calculations, unresolved previous comments. So effective shop drawing review improve quality, reduce field issues, and ensure compliance with contract requirements. Thank you so much for watching my video and subscribe for more structural content. Thank you.